in this section, we're going to talk about what's called u substitution. It's probably one of the most useful tools that we have for integrating. So first, let's start by reviewing. How do we find the derivative of y equals x to the 7th minus 3x all to the power of 4? So this is like a chain rule, right? We'd have to say, okay, what's inside the box? This would be my box on the inside. And they say, okay, take the derivative of the outside. So dy dx is going to be 4 times x to the 7th minus 3x. You keep everything inside the box the same. Drop your power by 1. Times, and now you need to do the derivative of what's inside the box. So 7x to the 6th minus 3. And that's our derivative using the chain rule. You know how to do that. Well, now, if you remember the antiderivatives or integrals, we first approach them as the opposite of derivatives, or to undo derivatives. You might think, well, how would we undo a chain rule? So if this was my derivative here, what if I wanted to take the integral of that and get back to what I started with? So what I started with doesn't look that complicated, but this certainly does. This part inside the integral is called the integrand. If you care, I might mention it a few times. But notice that it does look very complicated, right? And if I asked you to find the derivative or the integral right now, you would have no idea how to do this. So what we're going to learn how to do is called u substitution. And it basically undoes the chain rule for us. But to start with, if I look at this, notice it is 4x to the 7th minus 3x cubed times 7x to the 6th minus 3. Or it's the same thing as what I have right here. So since I just barely took that as a derivative, I know that what I started with was x to the 7th minus 3x to the power of 4. And because I take the integral, every time I take the integral, I need to add on the plus c. So how do we actually do this if we didn't just barely take the derivative? And we use what's called u substitution. It helps us kind of undo the chain rule. So what you do is you find a piece of the function you think could be called a u. That's why it's u substitution. And the way we pick u is we want to be able to find the derivative of u somewhere else in the integral. Okay. So to do this, I look, and the part that I pick to be u is often going to be inside parentheses or inside a square root or something like this. So I might pick this x to the 7th minus 3x because it's inside parentheses and it has the power of 3. So it looks like it's kind of in the most complicated set of parentheses maybe. So I might start by trying it. I might be wrong, but this is going to be my first guess for a useful u. So I'm going to say I think that u is x to the 7th minus 3x. And the reason I would pick that u is because if I take the derivative of u with respect to x, so take the derivative of u, I would get 7x to the 6th minus 3. So notice this is du. So this is u, and this is du. That's why I picked the u I did, because then the derivative of it showed up somewhere else. This is du over dx. So now what we do is we actually come through and we rewrite to get just du. What I mean by this is this du over dx was a symbol for us for how to find the derivative, or to find the derivative, but we can actually think about it as du as a variable and dx as a variable. And I could rewrite this as du equals 7x to the 6th minus 3 dx. The reason I would want to do that is because now let me rewrite my function. So this was 4 times x to the 7th minus 3x cubed times 7x to the 6th minus 3 dx. So what I'm going to do is I say, okay, this x to the 7th minus 3x, that's u. This entire 7x minus 3 dx, that entire thing is du. Now let's rewrite this. So this is going to be 4 times x to the 7th minus 3x, that's just u, so 4 times u cubed times du. Now you're not used to finding integrals that have the variable u, but we are used to finding them with the variable x or the variable t. This is just one new type of variable. We're going to take the integral now just like we normally would. We're not going to do anything special. So the 4 stays there. Now u cubed, we would raise the power by 1 and divide by my new power. Don't forget plus c when you take the integral. Those 4's cancel, and I'm back to u to the 4th plus c. Oh, and I actually meant to write that below. So I was just going to rewrite it here, to rewrite it to where it's just 4u cubed du. Okay, and then we integrated and we found out it's just u to the 4th. But my original problem had x's, not u's, and so my final answer should be in terms of x's and not u's. So come back up. What was u? U is x to the 7th minus 3x. So if that's the case, then my final answer is going to be u to the 4th plus c is no longer u to the 4th. We'll make it x to the 7th minus 3x to the power 4 plus c. So that is my final answer to my integral that we had. Notice it's the same answer that we had way up here. So what did I do? I picked a u, I took the derivative, I found du, I replaced my x's in my original function with u's and du's, took the integral that was now much simpler, and in the very end I put my x's back in instead of u's. Let's practice. So let's say we want to find the integral of 2x plus 1 times e to the x squared plus x dx. Now when you pick the u, again, lots of times you might pick the wrong u to start with, and that's okay. So let's say first I try to find 2x plus 1 as my u. Then the derivative would just be 2. Now do you see a 2 anywhere else? No, and that might not be that worrisome, but notice how we're still left with that troublesome x squared plus 2. So I don't think that was the best choice. Let's instead go for u equals this x squared plus x. Okay. Because if I take the derivative of that, I'm going to get 2x plus 1. So notice if that's u, then this is du dx. And so my derivative did show up somewhere else. Let's rewrite that as du equals 2x plus 1 dx. Now we'll rewrite our integral. So the integral of 2x plus 1 e to the x squared plus x dx is going to equal the integral. Okay. So now you come through and you say 2x plus 1, that's part of my du, right? In fact, 2x plus 1 and that dx together make up du. So I'll take those two pieces out and just replace it with the du. And now this x squared plus x, that's my u. So I need e to the u du. Let's condense that. So my integral simplified from this very complicated thing to just the integral of e to the u du. Again, that 2x plus 1 and the dx together made my du. So when I integrate that, the integral of e to the u is just e to the u plus c. And as our final step, remember I started with the x's, I should finish with x's, so go ahead and plug u back in. U equals x squared plus x back in, so this is e to the x squared plus x plus c. And that is my final integral. In this one, oh, notice I missed my dx. Every integral should have a dx. So again, I'm usually going to try and pick u as whatever's kind of inside the most complicated set of parentheses, or in this case, the square root seems more complicated than this parentheses since there's no powers or anything. So I think I would make that u. Let's make sure that works. So if u equals 5x cubed minus 2x plus 10, then the derivative of u would be 15x squared minus 2. And notice, there it is right there. Or du is 15x squared minus 2 dx. So let's make sure we've got all this right. So we had the dx is supposed to be there at the end. So this 15x minus 2 and this dx together give me du. and everything inside the square root is my u. So I could rewrite this as this is the integral of square root of u du. Or I could rewrite it as u to the 1/2 du. So now we just take the integral. So this will be u to the 3/2 divided by 3/2 plus c. And don't forget, your final step is to put the x's back in instead of u's. So u is 5x cubed minus 2x minus 10. So instead of dividing by 3/2, let's rewrite it as 2/3 times 5x cubed minus 2x plus 10 raised to the power of 3/2 plus c. And there's our final answer. Now, if you read your textbook, they have an official formula for u substitution. So if u is equal to some function g of x, and you have the integral of some outside function where g of x is the inside times the derivative of the inside, so derivative of g of x dx, then you can simplify it to just the integral of f of u du. Now, to me, that doesn't make any sense and I can't follow that as an actual formula. But I can follow the steps of u substitution. So I probably wouldn't even write this formula on your note sheet. I would just write down the steps or reword them as you wish that makes sense to you. So I picked a u, we found our du, we rewrote our function to use u and du instead of x's. Now this one we're going to come back to in just a second once we use it in our next example. Then we integrate and we rewrite our function with x's again. So those are our steps. So let's try this example. We want to find this integral of 5 natural log of x cubed over x dx. Okay, again, kind of where's your more complicated stuff? It kind of looks most complicated inside the cubed parentheses. So I'm going to guess that u equals 5 natural log of x. And then du would be, well, take the derivative of it, would be 5 over x, because the derivative of natural log of x is 1 over x. And if I rewrite it, du is 5 over x times dx. So now we come back here and we want to take this integral of 5 natural log of x cubed over x dx. This is my u right there. So I can replace this 5 natural log of x with a u cubed. And then this is like 1 over x dx. That's almost what I need. But do you notice this 5? There's a 5 here that I need, that I don't currently have because this 5 is going into the u. So I need a 5 here and I don't have it. Without that 5, I can't actually put du in. So how would we make a 5? The way that we make a 5 and we add an extra 5 in is you can times it by 5, but to balance it, we don't want to actually change our function. We can put a 1/5 on the outside because 1/5 times 5 is just 1. So that's why I said, if necessary, insert a special form of 1, such as like 1/2 times 2, or in this case, 1/5 times 5. Okay, because that now, this 5, the 1 over x, and the dx all combine to make my du. So now we have the integral of u cubed du, but we still have the 1/5 on the outside. So this is going to equal, the 1/5 is still there, u cubed would now be u to the 4th over 4 plus c. Or in other words, u to the 4th over 20 plus c. And put x's back in. So this will be 5 natural log of x to the power of 4 over 20 plus c. So again, this one was very much like what we've been doing, but our du needed a 5 and we didn't have a 5. So we can put the 5 in, but then we need to put a 1/5 on the outside to keep it balanced. We're going to do the same thing in our next example so you can see it again. So let's integrate 2 minus x over 2x squared minus 8x plus 2 to the power of 4. Notice here, my bottom parentheses to the power 4 look kind of like that's the more complicated thing. And so I would say that u is probably this 2x squared minus 8x plus 2. And the derivative of that with respect to x would be 4x minus 8. And so the derivative of u, or du, should be 4x minus 8 times dx. So when I come over here, this is my u, but do you see du? I only see a 2 minus x. And this is 4x minus 8, and those are not the same. However, they are fairly similar. What if I times this 2 minus x times negative 4? So what is negative 4 times 2 minus x? That would be negative 8 plus 4x, or 4x minus 8. Now that does match our du. So what this means is if I want to integrate this, I need to add in a negative 4 times my 2 minus x over 2x squared minus 8x plus 2 to the power 4 dx. So I need to have a negative 4 in there to make it work. However, I can't just add or multiply by negative 4 without changing it. So on the outside, I'll need to put a negative 1/4, because negative 1/4 times negative 4 gets me back to 1, so I haven't truly changed it. So now that we've done that, we can go back through. My negative 1/4 will still be there, times the integral. Now this negative 4, 2x, and dx together is all my du. So that's going to be just the du. And now this 2x minus 8x plus 2, that's u. Now technically this is 1 over u to the power of 4. Or if you prefer, you could rewrite this as negative 1/4 times the integral of u to the negative 4 du. That's slightly easier to integrate. So this is negative 1/4. Now u to the negative 4, you raise it by 1, so u to the negative 3, and divide by your new power of negative 3, plus c. And we can cancel a little bit, so this is positive 1 over 12, and u to the negative 3 means we'd probably bring it back down, so u to the 3, plus c. And as your final step, let's put x's back in. So 1 over 12 times 2x squared minus 8x plus 2 to the power of 3, plus c.